So this is Richard.
Hi, and this is Raoul.
You may have seen Richard, and it feels slightly odd to have a Richard on the left and a Richard on the right. Hopefully I'll get used to it.
Cool. So what are we going to be talking about today? This situation, right? This situation. What's going on here?
What are you doing in the picture, Richard?
That's not me. I'm not wearing a hat. You can see? You can see? But yeah, more importantly, what's going on here? These things, they look really out of place. This is a bit confusing, isn't it?
What about this code over there? Well, that looks equally confusing.
Yeah, that looks pretty confusing as well. What's going on? Question mark extends, comparable, question mark, super T. What's going on there?
Well, maybe we should talk about it a little bit.
Yeah, let's go through that kind of thing. So today we're going to talk a little bit about generics, past, present, and future. So we're going to go back and have a look at why generics was added to Java in the first place, what motivated that change. And then we're going to have a look at the present, at some of the features that you can use with generics in Java today, but which don't really get used that often, things which perhaps might be of interest, might solve some problems, but which people don't use. And then we're going to do a wee bit of crystal ball glazing and see what could happen to generics in the future.
So let's jump to 2004. Who remembers
2004.
this?
Who remembers this? A few people. The Facebook. You can see there's some fantastic developer UX going on here. They've used square brackets on the side as an aesthetic symbol.
Has
loads of zeros and ones.
To it.
Yeah, you can see it was designed for a mass market audience. But I think they've abbreviated the name since then, right? It's just called The now, isn't it?
Yeah, so I think it's not cool enough.
Yeah. Cool. So what else happened in 2004?
Well, generics were added to Java officially in 2004.
Fantastic.
So let's take a look at what they are, how code was written before 2004, and what we can do.
Yeah, so here's some vintage Java. That's what we call it, Java without generics. And if we just run this code, we'll see we get a fantastic ClasscastException. So what's going on here is somewhere in our code, we've got an iterator, we're pulling elements out of our list, we're casting it to a string before we print it out, and we have multiple entries going into that array list, right? And a couple of them are strings, but we finally get to an element that's an integer. And what could we do to solve this kind of problem?
Well, I see what you mean, Richard. So this sort of ClasscastException is a bit silly. Well, why don't we just create a class called string list or list string, and it's just going to contain strings. Therefore, you'll never be able to add an integer there.
That's good. That would be good. That would stop us from having this kind of error. It would make it a compile time error. But don't you think that's a little bit inflexible? Like, what if we need an integer list, a user list, all the rest of it?
Yeah, that's a good point. So we need to get a little bit more flexibility here. And I guess having those extra classes add code duplication. So maybe the language can help us here?
Yeah, so this is the situation which we need to think about when we're thinking about generics. We've got a situation we want to say, here's a list that can only contain strings, and here's an implementation of that list which is an array list that can only contain strings. And now we see our runtime error has been converted to a compile time error. And as time went on, Java enabled us to delete the extraneous duplication of type parameters on the right-hand side and infer the generic parameter from the target type. But the key point is we've moved from having an error at runtime to having an error at compile time.
And we avoid this code duplication if we had to create a class.
And we avoid this code duplication.
But it seems like, Richard, there is a trade-off here a little bit. So we've introduced generics, which add more complexity in the language.
Yep.
Even though we're getting sort of nice verification and concision.
Yeah.
So what are other languages doing in this space?
Yeah, so we've really got kind of a trilemma here. So you can pick your poison, basically. There's no magic win. You've got simplicity, static safety, and concision. And languages like Java, Scala, C# have generics as a feature, so they've got something that lets us to have that static safety without having to write your string list every time or your integer list every time. If you've got something that allows you to be concise, so have one list class and also be simple, you've got a dynamically typed language like JavaScript, Ruby, Python, that kind of thing, but they've given up on static safety.
What about Phantom? What's that language about?
So that's a language which has generic types, but only has 3 generic types. So things like lists and functions are generic, but users can't define custom generic types. So that's simple and statically safe. But if you want, say a more complicated data structure that's also generic, like say a ring buffer or something, you're in your own land. You're back to copying and pasting everything. And obviously some languages like C, for example, people will write hash maps which just take strings as keys. That's a thing that people do. So statically safe and simple, but it's not very concise because you need to do it every time for these different
It sounds like
types.
the magic bullet would be to get both abstraction, static safety, simplicity, and concision, but that sounds like it's not possible at the moment.
Yeah. You can only be so extraordinary. You can't magic things out of nowhere. But that's our trilemma. So, 11 years have passed. We use generics, right? Everyone uses generics.
Who uses generics on a day-to-day? Everyone loves generics. Awesome.
But what about these kind of features? Who uses intersection types on a day-to-day basis? 2 people over on the left. A few people. What about this curiously generic type parameters where they refer to the type, the curiously recurring generics pattern? Who uses that kind of thing?
Who came up with that name?
And what about wildcards? Who uses wildcards? More people use wildcards.
Who loves wildcards?
A few people love wildcards. So the key point is there's some generics patterns which have some uses, but
Less
frequently used. So what about intersection types? What's going on there, Raoul? Because I know about set intersection. That means you've got the elements which are in both sets, right? So what about intersection types?
Exactly. So set intersection, you've got 2 sets. The intersection, so the region here described in the middle, is what it is. An intersection type is very similar. So it's a type that extends both A and B. So kind of similar idea.
So what does that look like in code?
Well, let's see if we can come up with interesting use of intersection types. So we've got some code here. We've got some file input stream. We're reading some data. We're going to read it from the stream. So let's look up at the implementation of read.
So we're deserializing our person for a data input stream. So we read the person in, we read their name out, which is UTF encoded, and we read their age out, which is int encoded, and then we close the stream once we're done with that information. So what do we get if we run this?
So let's find out.
Yeah, that's because IntelliJ needs to delete that line there. Perfect. Let's rerun this again. Fantastic. So, it's Don Draper from Mad Men. I don't know if you can read that at the back, but he's now 89 years old because that show happened quite a long time ago. So, someone comes along and they change the requirements, right? And we also need to be able to take input from not only a data input stream, but a random access file. So, how are we going to cope with this, Raoul?
Well, so let's look at a bit of the code we've got here. So, we take this data input stream. So, we read the UTF, read the end, so that's supporting the data input interface. But on top of that, we're using this nice try-catch here handling using Java 7, so it also implements a closable interface. So if we inspect what random access is all about, we'll see that, well, it turns out it is also implementing data input, and it's also implementing closable.
That's cool.
That's cool, and the data input stream is very similar, implements the data input here. Fantastic. We'll look at file input stream. You can see that it's also implementing closable. So we've got two types here, data input stream and random access file, which share 2 same interfaces.
Yeah, so what we need is an interface that we can describe that type, and then we can correctly type that method, right?
Yeah,
so we can just say...
Let's try this. So we'll create an interface that is both data input and closable.
Cool.
Okay. So that seems like what we need, isn't it, Richard?
It is, but there's just one problem with that, isn't there? We've pulled in these classes from the core library, and we can't force them to implement that interface.
Yeah, so if I replace the code here Unfortunately, that doesn't work anymore because data input stream is not actually a subtype of data input closable. We'd have to modify the JDK library to make that happen. So we need a little trick here, isn't it?
Yeah, so let's have a look at how these intersection types can help us out.
So here comes the intersection type, where you can create this sort of a new type which extends both a data input and a closable. So the syntax to define a type parameter is to have it just in front of the return type of the method. And we're going to say it extends the data input and closable. Fantastic. We can replace that as an argument, and same thing here.
Cool.
Great. So it looks like this is working.
Yeah, so does it run? Does it run?
There's only one way to find out.
Yeah, we've got
Yes.
2 Don Drapers. Fantastic, 2 Don Drapers. Cool. So is this something that we need to use regularly?
Well, you could have potentially have a scenario where you're using different libraries and it's quite convenient to create this extra type. So that'd be a valid use case for using intersection types. We're going to be looking at another scenario where intersection types have been useful.
Yeah. Fantastic. So maybe you've not hit a point where you wanted to use both a data input stream and a random access file, but maybe you had a point where you wanted something that was implementing both of those interfaces, and you could have used intersection types as a way of faking the existence of that third type that you needed. But Raoul, what is going on here? Who would put this in that place?
I think it must be a C++ programmer.
It must be a C++ programmer.
I think that's what's happening.
They've mallocked a door handle in the wrong place. So, but what about this generics? Can we have a look at that? Can we just hone in on that for a sec?
Yeah, so this generic here is intriguing. So let's take a look. And you will recognize, Richard, that there is an intersection type here.
Yep. It's extending object and comparable.
But isn't comparable already a subtype of object? That's kind of odd.
It is. Why do you need to be both an object and comparable? If you're comparable, you're already an object, right?
Yeah, so to answer this question, we need to take a step back before 2004, pre-generics.
Really? Vintage Java again.
Vintage Java again. So back in the days, the max definition was like this. It would take a collection, non-generic, and would return a object. Okay?
Old school.
Old school. The problem is that this signature, we're stuck with it forever to preserve binary compatibility. Any sort of code that is calling max is expecting this signature. So the language designers wanted to bring generics. We had to sort of generify the collections. It'd be quite handy if we pass a collection of, let's say, integer, and we get an integer object back. So we'd like to have this type safety. So what can we do, Richard?
What we could do is we could make the generic parameter a comparable. I mean, everything in that collection has to be comparable, right?
Fantastic. So this is a first attempt at improving the API. So we introduce a new type parameter t, which will say you're comparable. We take a collection of t's as well, and the result will be this nice type parameter t. So that's great, but there is a little problem.
Yeah. So Java-C is going to erase our generics, and our method signature is now going to be a comparable max collection. So
which is a different signature to the one pre-generic. So we've got a binary incompatibility here. So the way to, the sort of hack that was introduced to solve this is to introduce an intersection type where the left-hand side is an object. And by doing this, the erased version of the signature is compatible with the one we had before generics.
So this is a lot more flexible. It's given us retain the backwards compatibility, but also had the type safety. But it's not so simple, is it?
Precisely. So some features bring great abstraction and flexibility, but often come with the complexity cost. So we've got this sort of dual forces going on. So you may have noticed the intersection type used also as a trick to make lambda expressions serializable. Who is using Java 8 in production these days? Fantastic. All right. So,
what
Richard,
about this one?
is this your house?
no, property in London hasn't quite got expensive enough that you need to have a door like that to be able to afford a house. But we're pretty close. We're pretty close. So
what's this type parameter here about?
Enum E extends enum
looks
E.
recursive somehow.
Yeah. So I think there's like this internet meme that covers this kind of topic. Yodog, I put a type parameter in your type parameter. Why would we actually do that? Why would we actually do that? Well, let's have a think through another example here. Let's have a think through about, say, an interface that's clonable. So our clonable interface takes a type parameter t and has a clone method that returns things of that type t.
Sounds reasonable. So should we create some class?
Yeah, so we've got a couple of implementations of Cloneable. We've got two people here. We've got John and Bob. Unfortunately, both John and Bob are confused, but they're confused for different reasons. So John's confused because when we try and clone John, he doesn't give us his own type back. So if John's genuinely being cloned, we should be able to reassign that to the same local variable, right?
Look up the declaration of a confused person and see why that's the case.
Unfortunately, confused person 1 is implementing clonable of string. Fantastic. So they're very confused.
But that should be picked up as a compile error, shouldn't it?
Well, we just said it was clonable of t, so it'll be accepted.
Fair enough.
What about Bob? I mean, Bob, Bob is clonable of confused person 2, so when you clone him, he returns himself. But unfortunately, we still have an abstraction problem here, because when we want to clone something twice and then print it out, we can say, this works with a confused person of 2. They'll clone themselves. They'll return confused person of 2. But if we come along here and say clonable of anything, clonable of question mark, we get a compile error, because you don't know that what you're returning, what's being cloned, is also clonable. We're losing information.
So I reckon we should update this clonable interface and tell this type parameter t that you're clonable yourself, isn't it?
Yeah, let's yodog the clonable interface.
So now, in the written type of clone, we can get t, which says explicitly you're clonable.
Exactly. And our confused person 1 can no longer implement clonable of string. So if we make them implement clonable of confused person 1, and then we return a new confused person 1 here. And we can return confused person 1 there. Fantastic. And now both of these compile. And if we run the code, we can see it prints out John and Bob. So they're no longer confused.
Great. So it looks like we've got the same dichotomy. We've added nice sort of abstraction, type safety.
Flexibility, but it's got more complicated.
It's got definitely more complicated,
If people are searching for this more information on this topic, should they be searching for Yodog? Is that the Google keyword to go for?
Well, academics they all like to have their special names for this stuff. They call it F-bounded polymorphisms. And I think the F here means something interesting.
Yeah. So if you hear an academic talking about F-bounded polymorphism, they've got a Yodog joke coming.
Definitely.
So, wildcards, these question mark things. What do we think about wildcards?
Well, I think the question mark says a lot about what they are and what sort of state they bring us into.
Yeah.
Very confusing.
I heard on the grapevine already that the question mark syntax was an ironic self-aware appreciation of the level of confusion that developers would have over the wildcard feature.
So
we could do that in more.
You may recognize them in some APIs. So his few methods are making use of both question mark extend and question mark super, which we'll be looking at. But the bottom line is you can see them all over the place, especially if you're using Java 8 and you're looking at the streams API, the collectors API. Those are everywhere. So what are they useful for, Richard?
Well, we have a lot of situations where we want to think about subtyping relationships. So subtyping, what's going on there? Let's have a look at a code example.
OK, so there's a bit of setup. So we've got a list of messages. Message is a simple class that has a field message, some getters. we've got some email message, we've got some text message.
And these are subtypes of our message, right? They extend message.
The extending message, so because as a result of that, there's subtype. So everywhere where we expect a message, we can use an email message or a text message by using the substitution principle. So let's warm up a little bit with that, shall we?
So we've got a method down there that logs a message. So that means we can log a text message and an email message, right?
Yeah, so text message. Hi, Richard. How are you?
Good, good.
We can log a email message.
Hi, Raoul. How are you?
Hi, Raoul. I'm doing great.
Fantastic. So what happens if we run that code?
So this is classic subtyping.
Hi, Richard. Hi, Raoul. So we can print them both out. But we can do this with arrays as well, can't we? That's this really, really cool feature. We can do this with arrays.
Yeah, so we've got this log all method here, which takes an array of message. So let's create some emails, shall we?
Yeah, email messages.
Emails, fantastic. Hi, Devox. Fantastic. So with this in hand, we can call a method log all to take emails.
Cool.
Let's run.
And we get that same email message printed out, hi, Devox.
So the subtyping relationship is extended to arrays. So that's quite flexible. It's quite useful in this scenario.
That's awesome. There's no downsides, right?
Well, I'm glad you asked, Richard. So let's see if we can have some fun here. So say I've got a message array. This is definitely valid, isn't it? This is subtyping.
Yep. Subtyping at work.
So I should be able to add a text message in my array of message, shouldn't I?
Yeah. Things are looking a wee bit murky here. So what's going to happen if we run this code?
Let's find out.
Yeah, we're getting an array store exception, don't we? So it looks like it works at compile time, but then blows up at runtime. We're back to square one, aren't we? How can we fix this?
Well,
this is a problem that we have with lists.
Well, we're back to square one indeed, because the message here reference is expecting message objects. So it's totally fine to add a text message to it. Unfortunately, emails here was also reference to an email message. So we've just sort of broken the type system. So indeed, let's see what we can do with list, because that seems to be a little bit of a language design problem, maybe.
Yeah. So in this case, we've got a log or message method that takes our list of messages here. Cool. So we can pass in our messages variable from the top, which is a list of message, right?
Yeah. So let's see what happens. So we've got a list of message here. We're just passing it to a method. Let's just run this to make sure we're happy.
Cool, prints
as expected.
But what happens? We might have, say, a list of email messages or a list of text messages. Can we pass them in as well?
It'd be quite useful to do that, isn't it? So we'll just pass the email messages, and well, it turns out this seems to be a compile error. So
really, the context which we're using these things in, it could take anything that's a message, couldn't it? It doesn't have to be a message. It could be anything that extends message.
Precisely. So the issue we had with the previous code with arrays is that we're actually trying to modify that array to add something that has a different type. But just passing that array of email messages to a method that takes the array of message should be perfectly fine. So what we can do with wildcards is to say $extends. So now we're having a list that is able to take anything that is a subtype of message. And our code compiles. So we've kind of added subtyping for generic. So we gain that flexibility.
Does it run as well?
I don't know. Let's see.
Fantastic. So it runs as well. So we're still safe.
But what's interesting here is that messages here, you wouldn't be able to add new objects to it because the wildcard is restricting the access to this type parameter.
Yeah. But, maybe I might want to come along and print things out through a different mechanism than just standard out println. Maybe I want to log our messages. Maybe I want to just test that a certain message is being passed in a test. So can we take like an interface or something that lets us consume messages? Ah, cool.
Yeah, so let's take a consumer. So consumer is this new interface that was introduced in Java 8. It's a functional interface, has one single method here called accept, which will take an object and returns void. So we can sort of pass this behavior to process the messages. So you want to print the message precisely? So
yeah.
Let's create a consumer for that. We're going to call it print message to make things explicit. Let's make use of Lambda's expression here.
Cool.
Fantastic.
So
we should update the code here.
Yep, that's a good idea.
To take the consumer and the message. Fantastic. So with this in hand, we can call log all. There is the overloaded version here that will take text messages and can take the message. So let's run this, see what happens.
Perfect. Our text message gets printed out. But, I mean, if we're just passing it to println, can't we just have a generic, like a consumer of object or something like that? That would also be safe in this situation, right?
Well, let's find out. So let's have a consumer of object, which is print. So we'll just get a reference to the printf
a method reference. Nice.
Ooh. And then, wait a second.
Compile error. Not so nice. Not so nice.
But surely, if I'm able to consume from a message, I should be able to consume from an object, right? You just get less specificity.
Well, I think we just want to say the opposite of our extends case, don't we? So can we do that?
So there's this other wildcard called !super, which solves this issue.
Cool.
So here we're saying consumer, anything that is a super type of message, and now the code is compiling. Let's run this.
And that works as well. Fantastic. Cool.
Great. So wildcards, useful feature to bring subtyping to generics, so we gain this sort of additional flexibility. But potentially we're adding more complexity again in the type system, isn't it, Richard?
Yeah. So !super is the kind of thing which historically people didn't use that much. But one of the things with Java 8 is that you have a lot of situations where you want to have parameters going into methods, like a predicate or a comparator. And often it's best to declare these types with !super and the type !super foo, that kind of thing.
But it turns out that those functional interfaces, they should always be annotated with !super, isn't it? We always want to have that flexibility.
Strictly speaking, you can sometimes get away with not doing that, but strictly speaking, they probably should be.
Well, let's revisit that in a second, shall we? So it's always interesting to look at research and see how certain language features are used. So there is a paper available at this URL which did an analysis of how generics are used in practice by looking at millions of lines of code of user applications. Turns out 90% of generics use is just list of string, array list of string, sets of string.
So similar to our kind of straw poll at the beginning, loads of people were using generics, but some of the advanced features weren't necessarily being used so much. And the other 10%?
Well, actually, it turns out the other 10%, those other complex features are actually used by libraries. So a lot of libraries are making of those complex features to bring additional flexibility to us users. So there's interesting dichotomy here again. Okay, so we've just covered intersection types, the curiously recurring generics pattern and wildcards. So interesting features that you can use. Should we take a jump in the future?
Yeah. Let's drive 88 miles per hour into the future and see how generics might change in a future version of Java. And this is the point where we really wish we had one of those lovely Oracle legal slides that says whatever we're saying might change and you shouldn't trust anything that we say. But we won't do that.
So wildcards are interesting. They're so-called use site variance. So you decide about the subtyping relationship yourself as a user in your code. So if you want to have subtyping for the list, you have to be explicit about it and say question marks and message. If you want to have a flexible consumer, again, you use the wildcards in the application side. So that's why they're called use site variance. The user is deciding whether they want this subtyping relationship or not. But Richard, is there an alternative to this?
Yeah, well, I mean, for things like our consumer, it looks like we could really say it should always be question mark super T. It looks like we could say that in the interface, like we could push the burden and the complexity more onto people writing libraries rather than to everyone. So how can we do that?
Precisely. So that's called declaration site variance. So the subtyping annotation is pushed on the library. Several languages have adopted this feature, such as Scala. So that means less complexity for the user. This is pushed down again in the library. So if we had this sort of declaration site variance in Java, so here we're using the sort of same syntax, we could say explicitly that the consumer is always contravariant and the stream is always covariant. So the data is always coming out, but for consumer, the data is always coming in.
Yep.
And on the user side, suddenly the code is more concise. We lose that extra verbosity of all those crazy question marks.
Or we improve readability at the same time.
But there is an issue with declaration site variance, Richard, isn't it? We've sort of got to decide whether the data structure is something that comes in, something that comes out. But a list, for example.
Yeah, we couldn't improve list, but something like a consumer where it always goes in, we can definitely improve. And those kind of use cases become more common with Java 8 with all the functional interfaces that have been used.
And there's the good news. There's actually a research project, so a JEP that is exploring the use of declaration site for variance for Java. So this is something that we may see in the future as well.
Fantastic. Making generics simpler.
So I heard there's a lot of talk of value types, Richard. Is that something else related to generics, a bit like struct in C? What is that all about?
Yeah. So we won't go too much into the details of what value types are, but the good old mantra is codes like a class, works like an int. And the idea is that you have a range of types added to Java which don't have the identity that objects do and act just as a struct of values. So why might we want to do that?
It sounds like we could have some form of performance benefit here, both in terms of memory layout and usage.
Yeah, so compactness is potentially one benefit we have. Objects have a couple of things at the top of objects. They have class pointers, so that's a pointer to some internal JDK data structure that says this is really an array list or what have you. And they also have something called a mark word. I won't go into the details of that, but it stores information, for example, when you lock on an object, what thread it gets biased to and things like that gets stored in the mark word. Now, these features take up space, so depending upon whether you're a 64-bit or 32-bit architecture, they may take up different amounts of space depending on the JVM architecture. So I don't want to say it's a specific number, but we're talking 8 to 16 bytes. And when you take into account the fact that objects get word aligned, so they get bumped up to be a multiple of the word size on your architecture, your 4-byte integer on a 64-bit JVM can be taking up 24 bytes. That's quite big. But we've got another benefit as well that we can think of.
Yeah, so since you're getting rid of all those references, it seems like we can flatten the structures and get additional sequential locality, isn't it?
Exactly, sequential locality or flatness. So if you've got an array of users, you've really got an array of pointers to user objects which are located somewhere in your heap. The user's got an ID and a name, so that's really another pointer to 2 other objects lying somewhere in your heap. By laying data out in this way, what we're really saying is we hate our CPU cache. We want it to do loads and loads of work. It's very hard to predict where those users, that ID or those name, will be located in memory, and it's thus very hard for your CPU's cache to start prefetching those values as you stream through an array, and it consequently leaves your CPU sitting there stalling for data a lot of the time. You won't see it with a tool like Top, but you can see it with a CPU cache profiler like Perf.
So Richard, that sounds fantastic as a user. Great, I get more performance, less memory consumption, but it looks like we're going to have both reference types now in Java, we're going to have value types. So that's adding even more complexity to the users, isn't it? How are we going to deal with those?
Yeah, things like this aren't really a free lunch. So there's a gnarly interaction there with existing generics. So, for example, by having something that's no longer an object, you don't have identity-based comparison. You don't have reference equality. You can't lock on it. You can't use your wait or your notify condition variables, things like that. So we need to have a way of saying if you've got a generic parameter, it's restricted. So it doesn't use those things in our case. So maybe we can get away with that for something like an array list. I don't want to say this syntax is the syntax that will be used or anything, but perhaps this kind of concept, which is being explored by some of the people at Oracle, to have the idea that it could be any type of generic type, so a value type or a reference type is the kind of thing. But on the other hand, this does make generics yet more complicated, and with yet more gnarly interaction with all the existing generics features. So it's far from a free lunch.
And the consequence of this work is that we'll be able to say a list is containing a primitive specialized int as opposed to a integer object. So that's work that's been researched. But Richard, again, how are we going to deal with list of int and a list of integer? Is there ways to sort of migrate between the value types world and the reference type world? How's that going to work out?
Yeah, so with primitives, we have this kind of this boxing concept that sometimes leaves us with additional memory consumption, additional indirection. And if you want to have a nice interaction between these value types and the existing Java object world, there's also some discussion about having boxing for value types. So again, there's perhaps a better interop story between primitives and the object world, between value types and the object world, but it's more complexity there. And there's an open question as to whether is that burden of complexity something that we all have to pay the price of, or just library writers? Maybe it's not so bad.
So there's another topic related to generics that you may be interested in looking up. The unbounded wildcards, type bounds, so different languages have different support for upper and lower type bounds. The erasure problems and the benefits of that. C#, C++, and Java all adopting different strategies here. So that's interesting to look at. Recommend looking at the lambda cube. So if you've heard of things like higher-counted types or dependent types, the lambda cube is sort of a general framework to think about abstractions and types.
And all the source code for this talk is all there up there on GitHub. And we'll put these slides online afterwards if you want to use them as reference material. Cool. So let's think about some conclusions here. We've noted that as new language features evolved, as things like lambdas were added, the patterns of generic usage evolved. Certain things like wildcards, which used to be very unpopular, have become a lot more popular. Over time, people have used more and more complicated libraries that stretch the generic usage more and more commonly. But a lot of the burden of this complexity, even though it is complexity, does get borne by library writers. So it's not the end of the world. It's still something we can manage.
So sort of general conclusion for this talk is that static type safety is great. We can get compile time verification, but typically it involves this trade-off between simplicity and flexibility. You can get lots of flexible code, but often you have this complexity that is introduced as well.
Cool. So hopefully you've enjoyed this talk, and if you want to learn a little bit more information...
So I personally recommend the Pro-Site version with Richard Warburton. That is a course on testing and an upcoming course on generics.
Yep.
Also a fantastic book on Java 8 Lambdas. Everyone should read it.
Thank you very much. Raoul also wrote a book called Java 8 in Action. It's a fantastic book as well. Highly recommend people read that as well. And if anyone's interested in training on Java 8 as a topic, we run a course which you can see the details of online at java8training.com. And Raoul also runs the Cambridge Coding Academy, which will teach kids to code, and also has courses for developers as well, right? Like kind of data science, machine learning, that kind of stuff. So that's pretty cool.
Fantastic.
So I hope you've enjoyed the talk. If anyone has any questions, we've got about 10 minutes left, so feel free to ask us some questions. Mario.
site variance in a future version of Java, but I believe this will be in conflict with what we have now, right? So this will make backward compatibility in some way, or not?
Well, we didn't say you had to remove use site variance.
Can you have both?
Well, Scala has declaration site variance, and they have a feature called existential types, which are basically fake use site variance or
So we're
use
thinking
site
of
variance.
wildcards in
Yeah, so
Scala.
they end up with both anyway in Scala.
But there's no conflict, right? If you take, let's take the consumer interface again. In your user code, you'll say explicitly it's a question mark of super. Fantastic. So if we annotate it to be contravariant, why shouldn't it work? You still got it specified in your user code. But if it's not specified in your user code, you just get that additional flexibility. So there isn't a compatibility issue there.
We should probably also emphasize the use of the word maybe at that point in time, maybe in a future version. But it was more there's some work there, it's definitely got some benefits, definitely problems which are becoming worse at the moment could become simpler with that kind of feature, and it would be a great addition if it can be fitted in.
Can't wait
Cool.
to see all the Java doc completely simplified, because we won't see all those question marks everywhere. That's going to be the benefit.
Cool. So does anyone, hey,
Earlier, we saw a local method that takes a list and a consumer.
yep,
Due to erasure, we cannot overload that method. We cannot have a second load.
right, yeah,
And that's because of generic erasure.
yeah.
It feels really inflexible when you actually, because you have different names to methods, while it feels you shouldn't have it.
So it's a... Yes, so the question was, a generic erasure leaves you with a situation where you can't overload methods on generic types, because at runtime those types aren't in the type signature of the method, so you don't know which method to dispatch on. It seems really inflexible, and it doesn't sound very nice at all. I completely agree that it doesn't sound very nice at all, but it's hard to think of a way to introduce that as a feature in a way that is compatible with existing Java code in a kind of migration compatibility way. I mean, there was a lot of discussion when generics were first added to Java over different scope for this kind of feature. There was the C# route, which is like have two collections libraries, but have better generics in the long term. And then there's the Java route, which is have one collections library, but kind of pay the price going on. And I don't know. As I said, I think we talked earlier about kind of pick your poison on the trilemma. This is another one of those pick your poison things. Yeah, it's bad, but is the alternative worse? Probably not. Probably, it's kind of a matter of opinion. I don't know if you have any other thoughts on that matter. Yep. Cool.
A question about generics inheritance. So it's getting more and more complicated in the future. What's your opinion about that?
Yeah, well, I mean, maybe I'm stealing all the questions here.
What's
Al,
the
maybe.
question?
The generics inheritance is getting more and more complicated if you consider the future of the generics. What's your opinion? Is there going to be a block to the generics?
Generics inheritance.
Yes.
So you mean things like the type bounds that we saw earlier?
No, if you consider you have a generic class and then you inherit with a different another class.
Which is also generified.
Yeah.
You mean it's like a foo list extends array list type scenario?
Okay, yeah. Do we think we will see that in the future as a pattern happening more and more? Type of thing.
I think the question was, is it more complicated? Is it becoming more complicated?
Oh, I don't have a specific opinion for that. So from a library design point of view, I think this pattern, you see it quite repeatedly. If you look down the JDK implementation, you will see lots of patterns like this. In user application, less so. So I think it's definitely a problem for library designers rather than for us users. If you look at the Java API, there's definitely a lot of generics and wildcards that were introduced, making use of those rich features, especially the collectors API, if you've been looking at that. But for sort of day-to-day developers, I think we won't see that much of these users, and that's proven through some research that is showing the use of generics in practice.
Yeah, so it could still be okay. Cool. Any other questions? Hey.
Yes. Is there anything coming up in Java 9 or 10 or anything that is going to try and make variance and contravariance be more intuitive?
So we looked at so is there anything coming up in Java 9 that's going to make covariance and contravariance more intuitive?
Yes, that's the question.
So there's a JET proposal which we looked at that adds declaration site variance to make that easier to understand for developers, so pushing down the complexity in the library. But it's a JEP, so it's
blatantly not happening in the 9 time frame, but maybe in the future. That would be nice.
Well, that is not really making it simple, it's just hiding the complexity away, which is good. But is there anything else to try to make it simple to understand? Or,
So I think I take your point. It is hiding it, but I think it is also making it simpler because you're saying it's going to be one way and one way forever, rather than different people can do it in different ways all over the place. It removes the scope for someone missing out a question mark extends or question mark super where they should have left it in, or getting it wrong, or misunderstanding the feature, all sorts of things like that. So I think it does genuinely make it simpler for most people.
So what you could do is you could also infer the variance annotation. So if you take an interface like consumer, it could be inferred that it's always contravariant without having that explicit type annotation. Whether that simplifies things or not, I think that's another debate. Having it explicit, I think, adds documentation. So that's an improvement.
Yeah. Peter?
In Scala, you have these additional tuple types. In Java 8, you only have one functional interface. So will they be extensions to that function? Single argument, return?
So in Java 8, if you want to introduce a sort of a so-called function type, like in Scala, you can always introduce a new functional interface with a name that you're creating, and then the structure of that functional interface can be a function that takes n number of parameters with a result type. Scala has this function types syntax that you can use on top of that. I don't think that's something that's explored for Java.
And if I'm not a Scala expert, but my understanding is the compiler desugars this to refer to things called like function 1, function 2, function 3 for all the different n argument versions that they have anyway.
Yeah,
Up to 20.
I don't know.
Yeah. To be honest, if you want 21, you're probably a bit crazy anyway, right? Cool. Yeah, so I don't think that's such an issue, because as Raoul says, you can just have another functional interface with one more than whatever exists, but please stop at some number.
Names are good.
Preferably less than 20. Hey. Oh, yeah, totally requires a JVM change. I'm not sure if there's much else to
New bytecode introduced. If you're interested in that stuff, just type state of the specialization, Google, and you'll find a nice document by Brian Gutz, which may be a bit out of date now, but it explains all the sort of research that goes behind it and the design options and what's been discussed. Also recommend looking at the Valhalla project mailing list. All this kind of stuff is being discussed, so you can stay in the loop.
So the Valhalla project mailing list, the Valhalla project has basically like a fork of OpenJDK where these things are being prototyped in. And the current prototype doesn't have value type implementation that's like nice and usable, but there is primitive specialization stuff that is usable and playable, aroundable, and you can have, like a list of int, and it will get JIT compiled and refer to a proper primitive int under the hood, and that kind of stuff. It's prototypey, it's buggy, but that kind of stuff is there and available to play around with. So I'm sure if you just download it, build it, try it out, and give them feedback, that's also a really good thing to be doing as well at this stage, and a really good way to learn more about this kind of stuff. Cool. Any other questions? No? I think that's it. Right. Thank you very much.